with system through this RS-232 cable, serial cable. Then give supply connection. Then keep the processor in switched off condition itself. Okay. Since initially the all the programs will be written in C codes, that should be converted into assembly code. So till we convert that into assembly codes, the processor need not be required. Okay, so we have to keep the processor in switched off condition itself. Okay, so in system there is an app called CC Studio, which stands for Code Composer Studio. Okay, for that one more app is there, that is Setup CC Studio 3.1. Of course, advanced versions are there. We are having only this. Okay, so in this a list of processors are available, which means this Code Composer Studio can act as any of these processors, which means it can compile the program for any of these processors. It can convert any of these processors assembly codes. Okay, so that is the meaning. So in that there are three options called family, then platform and NDNS. So in family we have to choose C67XX. C67XX. Then in platform choose simulator. In NDNS choose little. Okay, so now for these three conditions, what are all possible processors? Those are only listed. So among that we have to choose C6713, since it is our processor. Just double click over that so that our system is now defined suitable for this processor. Okay, then give save and quit. Then it will ask start Code Composer Studio on exit, then give yes. So sometimes it automatically opens CC Studio 3.1. If not, we can close it and we can open that particular app, CC Studio 3.1. Okay, see in that we can find the list of projects, but of course there is no project created till now, so that's why the project folder is empty. Okay, so what we have to do is create a new project. So new, and this project name, say I'm going to have a program for multiplication of two data. So I am giving the project name as MULT. Okay, then this I have to save this in a particular folder. So parallelly with this project creation, in desktop create a new folder. I am giving the same name for that also, MULT. Okay, MULT. Now in this project I have to save that project in a location, so that location should also be our created folder, which is available in desktop. So choose that particular path. So in desktop, MULT is the corresponding folder, so give OK. Choose that path. So automatically its corresponding path is assigned. Users, administrator, desktop, MULT. That is our folder. Then nothing else is required. Automatically the processor 320C67XX is chosen. It is of executable type. So only these two we have to specify. Then give finish. So you can look at this. After creating a project, the project name is assigned. Means new project is created with empty folders only. Okay. Now what we have to do is we have to create the files. Okay, So source code is to be defined, then command files should also be defined. Okay, then only the project will follow the source code with the conditions provided by the command file. Okay, so for that purpose files are to be created. So those files should also be available in our folder only, newly created folder only. Okay, so if you refer this folder which we already created, that empty project will be there. MULT is there. Okay, that is an empty project. What we have to do is we have to create the source code. So that is created through this. So create a new file that is as source file. Okay, so the file content I am just taking from the folder VSK6713. So in that I am finding basic programs. In that multiplication is there. Then C code I have to choose. So MULT is there. So copy all those codes and paste it in our new file. Okay, now save, give save as. That file should also be available in our desktop folder only. So in desktop our folder name is MULT. So in that I have to save this file. This file is actually C or C++ source file. So choose that file type as C or C++ source file and give the file name. I am giving the same name only, MULT. Okay, so save. So what happens is, see, if you refer this folder, of course my file is there, MULT. That source file is there. Okay, now two more files I need. Actually in this VSK6713 I can find CMD files, that is for command files. Copy down both of these two command files and paste it over our folder. So those two files are there. Okay, so now if you refer our folder, the empty project MULT is available, source file is there, command files are also there. Okay, but there is no interlink between these files and project. So what we have to do is, you come to again this CC Studio, then go in project, then go with add files to the project. This only will link the files with project. Okay, so choose that first source file. So C++ source file. So in that our folders file is listed. So you just choose that and give open. Okay, now if you refer our project folders, in that, see in source folder you can find our file. Okay, newly added file is there in this folder. Okay, after that also you go with project and add files to the project, then give the file types as all files. In that you can if you choose our folder, then in that you can find these two files which are command files, vecs.asm and VSK6713. So those two are available. So choose both of them and give open, so that now all those two are also combined. So now our project is, it was empty previously, now it is added with one source code and two supporting files, means command files. Okay, so we now linked with this project. Now our project is ready to execute. Okay, so what we have to do is, initially this purpose of Code Composer Studio is it has to do the compilation, correct or not? So the project is to be now compiled. So for that we have to do some initial settings, configurations. So for that, go in project, give build options. So in this build options, in this compiler we have to choose this target version as C671X. Okay, next, no other changes we need, just you choose the linker, give OK, and sorry, 671X, then go with the linker. In that, give heap size and stack size both as 400. Both as 400. Then library file is to be included, that is capital RTS 6700.lib. Okay, RTS stands for real time simulator. Real time simulator, which is common for the family of processors which starts with 67. That's why RTS 6700 is given. Okay, then this .lib extension should be given. Without that it won't work. Okay, that this is actually case sensitive, so that lib extension should be in small case. Okay, in smaller letter. Okay, okay, only these are enough, then give OK. So now I configured for building the projects. Okay, so next go with project, give rebuild all. Okay, so that if you refer a project, it will be executed. Okay, executed after compilation. It will be compiled. After compilation, we will get the result of the compilation as this: build complete with 0 errors, 0 warnings, and 0 remarks. Okay, in all the programs you cannot expect these things perfectly. So, but the only requirement is it should have only 0 errors. Warnings can be anything and remarks can be anything. Sorry? So it should have 0 errors. Then only we can execute the program. Understood or not? Okay. Okay. Now everything is completed with this app, CC Studio. Okay. So close this. Compilation is over. Okay. Now go inside our folder. You can find 2 more newly created and automatically created folders called debug and mult scenes. Clear? Okay. So you can find within this debug folder, you can find the mult.out file. Okay. So that is the equivalent file for our C code file. Got it? Okay. Just you refer and close it. Next, go in VSK 6713. So in that, you can find how to ASCII converter utility. Okay, go in this folder. In that, ASCII conversion utility is there. Go in that. Okay. So the use of this utility is it can convert the out file into ASCII file. Okay. I told you no. The ASCII file can only be transferred to the processor. Correct or not? So we got out file here. Okay. That should be converted into ASCII file equivalently. So choose our file. So in that, where we kept in desktop, MULT is our folder. Within that, as I told, debug is the folder which holds the mult.out. Okay, so choose that file. Okay, that file is chosen. Give convert. So just within the fraction of second, you will get the command as conversion finished. Okay, now copy that path in ASCII file. Copy the path of that file, ASCII file. Got it? So just path is to be copied. Path is to be copied. Then close this utility also. Okay, so now what we obtained is the C code was compiled through the CC Studio. Then after compilation, it was converted into ASCII code. Okay, now switch on the processor, because now only we are going to use this. Okay, you just press 1 or 2 times the reset key of this. This is only reset key of this processor. Okay, so that the processor will be ready for use. Okay. Okay. Now some other can hold. Now go. Yes. Okay. So now go with this VSK debugger. Okay. VSK debugger. So in that, initial setting is required. That is, we have to make the confirmation that whether the system is connected with our processor or not. Okay, so for that we have to check initial setup. Then only we can use this. So what we have to do is, since we are using serial connector, you keep that in mind. So go with serial. Okay, go in serial. In that you can find port settings. Port settings. Okay. So in port settings, you have to choose the communication port as COM, that is COM1. Okay, there are normally two serial communication ports in a system, COM1 and COM2. Always we have to choose COM1. Okay, so already it is with COM1, so leave it. Next we have to choose baud rate. Baud rate is nothing but data transmission rate, data transmission speed. Okay, so the suitable speed for this processor is 19,200. Because the system is of course faster than this, but these two should be matched. Correct? Otherwise, if it is the data is quickly sent, then if it is very slow, then data will be lost. Correct? So their speed should be matched. The matched speed or matched baud rate is only this 19,200. So choose that. Okay, only these two options, COM1, 19,200. These two are to be chosen. Then give one time again reset the processor. Now give auto detect. Okay, now it is saying, the system is saying that VI DSK hardware is connected. Display is there. That is found in COM1. Okay, which means in the system's COM1 port, this starter kit is available. That is the meaning. Okay, now close it. Okay, nothing else we are doing. Just we are checking whether these two are properly connected or not. Sometimes if it is not proper, we have to change the RS to 32 kV. Got it? Okay. Next, since I am going to do the multiplication program, okay, so before going to execute the program, you just check what is the code available with that. See here. So initial commands only include standard IO.h, include math.h, then void main, normal C codes only. Then initialization, integer, star input means this input, the variable name will be acting as a pointer. That is the meaning. Then these two are the variables we are using, first value and second value. That is FIR VAL is for first value, second value. Okay. Okay. Now, since this input is just a pointer, it will be pointing the address 8,000,000. Okay. 8,000,000 is the address of data. That's why it is data address. Normally in memory, two parts will be there. One part will be used for holding the programs. Another part will be used to hold data. Sorry? The memory part which is holding the program is called as program memory. Memory part which holds the data is called data memory. Got it? Okay. So in data memory, we are going to save the data. Okay, that data memory address is only this 8,000,000. Got it? Okay. So in that particular address is taken as input. So in that input 0 will be holding, means initial memory location, first memory location will be holding first value. Okay, then next one, that is input of 1 will be used for holding second value. Got it? Okay, then this first value is multiplied with second value and the available answer will be saved in input of 2. Got it? Okay, this is the program we are using. Okay, save. Close it, then close this also. Come to debugger again. Now start again. So in this, again go with serial, then go in communication window. Okay, communication window. Okay, so in this communication window is just for communication between the processor and user. Okay, whatever is the input you are giving, if you are giving that as a data form, that should be given through this communication window. If the output is also in data form, text form, then you can receive through this communication window. Okay, just like MATLAB's command window. Command window is used for the communication between user and the system. Correct or not? Like that only this communication window. Okay, so since we are having anyway multiplication program, we have to give two data, then the result will be displayed, that is taken from this. Okay, for this purpose. So after opening the communication window, immediately after that you press reset key of our kit. Okay, the purpose is whatever is the process is done at background, it will be getting ready. For that purpose only we have to press reset key. Clear? It doesn't matter many times you are pressing it. But then just a moment. Before this, I forgot a stage. Actually, go in serial. Before this, one more stage is there. We have to load the program. Okay, then only we can execute. Right? So, open load program. In that, it asked for the file name. Correct? See, we actually copied the ASCII codes path. Correct or not? So, paste it over here. Paste it here. Okay, that is enough. Now you see this address of this program, 4 times 0, 6000. Okay, address of this program. So obviously this, what is this? Address of program memory. Okay, whatever is our program, that will be saved in this from the starting address. Okay, 4 times 0, 6000. That is the starting address of program memory. Okay, now you just enable this, that is execute after this completion. Then again reset your kit, because now immediately we are going to give OK, because if it is ready then only it can receive the codes. Okay, okay, give OK. Okay, you can refer this much data are downloaded, that display is there. At that time this green LED will be glowing. Okay, understood or not? Okay, then the data, complete data was were transferred to this kit. Now the system part is over. Okay, so this many number of bytes were successfully downloaded. That is the information after this downloading process. Okay, all the codes are now dumped into this processor. Okay, processor is also having memory. Its memory is only that 0, 6000. Okay, give OK. Now go in serial. Program is available with processor. Now we have to execute. Okay, go with this communication window. Reset the kit. Okay, give the command as capital SP. SP means substitute packet. Okay, space. What is our data memory address? In the program we mentioned 8000. Okay, so give 8000. Okay, that is the address, data address. Okay, so press enter. Okay, you can refer like this. Substitute memory, the address is there, some data is already there. Okay, 8000 is our address. Then some data is displayed, that is already existing. Clear? Is it clear now? Okay, now we have to give our own data. Okay, if I want to do the operation 5 into 5, okay, give the first data as 5. Okay, since this is a 32-bit processor, 32-bit processor means totally 32 bits will be there in a single word. Okay, but in memory location, each memory location is having capacity of only 8-bit. Okay, so how many locations are required to hold this 32-bit data? One location has the capacity of 8-bit. So 32 bits I want to store. 4 locations, 4 consecutive locations are required. Okay, so if I give 8000, just it is the initial address. So 3 more locations it will automatically take to hold our data. Clear? So I have to give again 32-bit data. 32-bit data. Since I am going to use only hexadecimal codes, so for individual hexadecimal digit, 4 bits will be required. Normally for representing the hexadecimal code, for example A, then what is its equivalent binary representation? For A, 1010 wow. So how many bits are used? 4 bits. So equivalently for a single digit of hexadecimal code, 4 bits should be used in binary. Okay. So here for 32 bits, how many digits I have to give? 8 digits. Correct? Each digit is represented with 4 bits. So 8 into 4 will be 32. Correct or not? So 8 digit data I have to give. So what I am doing is, initially I am fixing 7 different zeros, then 8th bit alone I am giving with some non-zero value. Clear? So 1, 2, 3, 4, 5, 6, 7 zeros, 5. That is my first data. Okay, press enter. Clear? So it shows the next location address and its previous content. Okay, this also I am going to give as 5. So 1, 2, 3, 4, 5, 6, 7 zeros, 5. So what I want to do is I am going to do 5 multiplied with 5. Clear? So press enter. It is showing next location data that we don't require. So press dot so that it will come to the prompt again, DOS prompt again. Okay. So now only 2 data I am using. So I have given 2 inputs. That is enough. Now we have to execute the program. For execution, we use the command go in caps. Okay. So give go, leave a blank space, single space. Then our program address is to be specified. What is our program address? 4 zeros, 6000 now. Correct or not? 4 zeros, 6000. That is only the program memory address. That is to be mentioned. So go, blank space, program memory address. That is enough. Press enter. So you are getting executing command. Executing. That means the program is executing. Just within a fraction of a second it will complete. So press reset key of the kit. Okay. So the execution is completed. After execution we have to check the result. Okay, where we can find the result? See here, my first data is available in 8000, 1000. Second data is available in 8000, 1004. So my result is available in next location. Next location address is what? 8000, 1008. Correct or not? So again go with SP caps, give blank space, give the address 8000, 1008. Clear? So press enter. So what is the result? 19. 19's equivalent decimal value is what? 16 plus 9 no? 16 plus 9 is 25. Correct or not? 1 into 16 plus 9. Okay, so that is 25. So 5 into 5 is 25. So we are getting correct result. Clear? Understood or not? So this is the processor program execution. Clear? Thank you.